Welcome back to the next video where we are going to be discussing about the next formula under the whole family of APs. So just as a recap, what exactly is an AP? An AP is a sequence of numbers, so it's an ordered set of numbers whereby the difference between each number is a constant. So now that we understand that an AP, right, the general term of AP, so I will just write it this way, right? Let me just zoom in. So let Tn be the general term of an AP. Right, we know that Tn over here is basically just your T1 plus n minus 1 of D, right? It's the first term plus the common difference. And how many times do you add the common difference? You add the common difference n minus 1 times. Okay, so that's the whole idea behind it. So now for the next concept is the sum of the first n terms of an AP. Or rather, this is also known as your series of an AP. So this is your series of an AP. And I'm going to be using an example over here, giving you the example, running through the idea behind it with you so that the formula makes sense to you when you actually get to it, right, at the end of this introduction portion. So let's say I have an AP that looks something like this, okay? Let's just say. Let's say my AP is this 3, 5, 7, 9, 11, 13. Let's say this is an AP, right? We know that this is an AP because the difference between each term over here is a constant of 2, right? The difference of 2. So when I say what is the sum of all terms in this sequence, you see that I have T1, T2, T3, T4, T5, T6. So when I say what's the sum of all of the terms in this sequence, I'm really just asking the question of what is the sum of all of the 6 terms, right? So typically when we want to find the sum of all the 6 terms in the sequence, right, we will say S6 over here. So if we want to find the sum of the first 5 terms, then we'll say S5. But now we want to find the sum of all the 6 terms, we are essentially finding S6 over here. So the 6 over there denotes up until the which term. Now, of course, we can manually key this into our calculator to get the answer, right? But the point over here is not to punch the value into your calculator. The point over here is to understand the formula or the approach behind this so that even in the future whereby let's say you are supposed to find the sum of the first 1000 terms, right, you know how to do it in a very sophisticated way. And the idea behind it is like that. So you see that the beautiful thing about AP is that there is a pattern. You realize that the first term and the last term, these two adds up to 16. Right, I'm just going to write this out over here. T1 plus T6 gives me 16. You also realize that T2 and T5, apologies, T5 here. Because these two adds up to give me 16. And last but not least, I have T3 and T4. These two adds up over here to give me 16 as well, right? So what is the pattern that we can see here? We can see that in an AP, the first term and the last term, as we keep forming pairs and pairs, we form many pairs that add up to the same value, right? So we can see that over here, we have 3 pairs of 16. So 3 pairs of 16 is actually a formula in itself. How do we derive 3 pairs? If we have 6 terms and we divide it by 2, we'll get 3 pairs. So I'm just going to write it here, below here. Generalize. For n terms, how many pairs will we have? We will have n over 2 pairs. Now the next part over here is the 16. How do we actually get the 16 over here? The 16 is basically taking the first term, which is T1, and the last term. So I'm just going to write it as the first term plus the last term. We can get 16 by taking the first term plus the last term. Now, the reason why we choose the first term and the last term as opposed to the second term and the second last term is that the first term and the last term is the more easier ones to get, right, in any question, right? Usually when we do any question, we would most likely know what's the first term and the last term, right? Probably there's a lower chance of us knowing what's in between the first term and the last term, but there's a higher chance of us knowing what's the first term and the last term. So that's why when we think of it as what is the sum of the pair, we would usually think of the first term and the last term, adding them together. Right, but of course, you can see over here, you can get the same value by taking T2 plus T5, T3 plus T4, right? Just to make things simple for us, we can think of it as just adding the first term and the last term. So another way to write this would be T1 plus L over here, whereby L, it means the last term, like L is the last term, right? Or you can think of it as Tn, like the n term, Tn. Okay, I'm just going to write Tn over here. Or you can write L, however you want to remember it, right? So the formula for S6 over here is basically just 3 times 16, or rather I have 6 terms divided by 2 times 16, which gives me a value of 3 times 16, which eventually gives me 48 over here, right? So the sum of all the 6 terms gives me 48. Now to generalize this for Sn of an AP, as mentioned, it's just your n over 2 because this is the number of pairs multiplied by the first term and the last term, right? But the first term over here can be written as a. And the last term over here, remember the formula for your general term Tn equals to a plus n minus 1 of d, right? Your last term can be also written as a plus n minus 1 of d. So you can write it t1 plus tn, or you can abstract it down and write it in terms of the first term and in terms of the common difference, which means that you also can write it as n over 2 times 2a plus n minus 1d. So there's two ways of writing the formula, but they all essentially mean the same thing, right? That is basically the formula that I wanted to drive towards for this video over here, is that the sum of the first n terms of an AP follows the formula of n over 2 times first term plus last term. N over 2 gives me the number of pairs in the sequence, while T1 plus Tn is the sum of the pair. And this pair will keep appearing again and again and again. Now, at this point, I just want to address an edge case that I always get questions on, right? Which is, what happens if there's odd number, right? Let's say I have a sequence whereby it's 1, 3, 5, 7, 9, right? You see that these two adds up to give me 10, right? So let's say this is T1, T2, T3, T4, T5. So you know that T1 plus T5 gives me 10. This one forms one pair. And over here, 3 and 7, T2 plus T4 gives me 10, right? But then T5 over here has no partner, right? So you can see that T5 is just a standalone of 5 over here. So how do we actually find the sum of this AP? The truth is that the beautiful thing about this formula on the right over here is that it accounts for this type of edge cases as well. Is that when you take n divided by 2, right? Over here, n divided by 2 is essentially 5 divided by 2, which is 2.5 pairs, right? You realize that the 2.5 pairs, the 0.5 pair over here is essentially this, right? T5 over here is considered as a 0.5 pair, right? Because if it's truly a 1 pair, we take 5, if 5 is 0.5 pair, then 10 would be 1 pair, right? Which is essentially the value of 1 full pair over there. So in short, you don't need to worry about a sequence or an AP having odd number or even number terms, because the formula over here automatically accounts for both types of scenarios. Okay, because if you have an odd number of terms inside a sequence, 0.5, the decimal pair, is basically the representative of that singular term if it was odd number of terms. Okay, if not, that's it for the introduction. I hope that this makes sense. Now we're going to tackle two questions over here. We're just going to be tackling two different questions here to make sure that you really understand the concept and able to apply the formula. So make sure you took down the formula already. If not, we will actually jump right into tackling this question. So feel free to pause this video, try it out. If not, now I'm going to be going through the question. So the question is given as such. I have T1 and T3 of an AP, negative 50, negative 42. So first thing I'll write is that I'll let Tn be the general term of this AP. Tn, once again, is T1 plus n minus 1 of d. So my T1, I know it's negative 50, right? And T3, I know is negative 42. So I can sub this into the formula to find out what's my d. I know that my negative 42 is essentially negative 50 plus 3 minus 1 of d. Negative 42 is negative 50 plus 2d. And from here, I can derive that my d is actually just positive 4 over here, right? Because negative 50 plus 8 is negative 42. So I know that my general term is just negative 50 plus n minus 1 of positive 4. Okay, so this is every single thing that I can infer just from the first sentence alone. So you actually need to do this in order to tackle this question. So they want you to calculate the value of the first positive term of the series. So note that first positive term of the series, this is not the concept that we have learned in this current section yet, right? Because all they're asking you is, what is the first term Tn that is bigger than 0? So this is actually an inequality question. I'm just going to let the general term, negative 50 plus n minus 1 times 4, bigger than 0. So n minus 1 times 4 is bigger than 50, n minus 1 is bigger than 50 divided by 4, and 50 divided by 4 will give me a value of 12.5. So n minus 1 is bigger than 12.5, and n is bigger than 13.5 because I shift the 1 to the other side. And therefore, the least value of n would be 14, as n must be a real positive integer. And so I know that when n is 14 or more, it will be positive. The whole term will be positive. So from this point onwards, all I need to do is to just sub the value of 14 into the equation. Because once I sub the value of 14 into the equation, I'll be able to find out what's the first positive term. So I sub n is 14 into Tn over here, and I get that my Tn will have a value of negative 50 plus 14 minus 1 times 4. And Tn will have a value of positive 2. Oh, okay, I'm just going to write 14 here. Okay, T14. T14. So that's the value of the first positive term. Yep. Okay, next. Sum of all of the negative terms. Now this is where it gets a little bit more interesting, right? So over here, we know that T14 is the value of the first positive term, which also implies that T1 to T13 are all negative, right? It implies that. So when we say the sum of all the negative terms, it's essentially the sum of the first 13 terms, right? So they are asking us what is T1 plus T2 plus all the way until plus T13, which is basically just S13, right? So how do we find out the sum of all of the first 13 terms? Using the formula above, right? In the first 13 terms, how many pairs are there? There are 13 over 2 pairs, right? And then this will be T1 plus T13. Right, because we take the two edges of the sequence. Now, what is T1? T1 over here is negative 50, right? We know that from the question. Now, how do we compute T13? So T13, using the general formula over here, right, this general formula, is negative 50 plus 13 minus 1 times 4. So we can just plug it inside here, right? So it's negative 50, which is T1, minus another 50, plus 13 minus 1 times 4. And then you just keying this whole thing into a calculator, you get a value of negative 338, which is the final answer to this first portion over here. Alright, so this is the answers to this question over here and the thought process behind it. Let me know if you got any questions for this. If not, we'll be jumping into the next portion. Again, feel free to pause this video to try it out right now. If not, we will tackle this question together. So, the sum of the first 40 terms of an AP. Once again, sum, first 40 terms. So this is S40 of an AP. Immediately I see AP, the thing that will come to my mind is the general term, right? Tn is T1 plus n minus 1 of D. First term is A, common difference D, right? The sum of the first 40 even numbered is negative 1440. And they say even numbered terms. So how do we actually make sense of this, right? I'm just going to draw out the sequence. Okay, so this is the sequence, which is the AP. T1 plus T2, T3, T4, T5, T6, all the way until T40. Okay, just imagine it this way. When they say the sum of the first 40 even numbered terms means T2, T4, T6, right? All these over here are examples of even numbered terms, inclusive of this, right? This one and this one. Examples of even numbered terms. So when we add the even numbered terms together, the first 40 of them, we get negative 1440. And since we actually jump, we don't include T1, we don't include T3, we don't include T5, we know that this will naturally extend beyond T40, right? So this second sentence over here actually implies that we are taking T2 plus T4 plus T6, and then we are adding it all the way until T80, right? Whereby here is the first term, the second term, the third term. This is the 40th term of this sequence that only contain even numbered items. So this one actually forms a different sequence. So what's the sum of all of the first 40 even numbered terms? So we know that T2 add up all the way until T80, right? Of course, T2 plus T4 plus T6 all the way until T80. The total sum is S minus 1440. Over here you can see is S minus 1440. So S minus 1440 can be written using the formula as what? Given that we have 40 terms, how many pairs do we have? We have 40 divided by 2 pairs. Now, how does one pair look like? One pair is essentially T2 plus T80, right? Every single pair looks like T2 plus T80, right? Every single pair has the same value. So T2, I'm just going to write 20 here. T2 has a value of A plus N minus 1, or rather A plus D, right? This is T2. So you see that T2, the second term, is essentially A plus D. Now, T80 is essentially A plus 79 of D over here, right? Because you add D 79 times to get to T80. So combining these two, I get 20 times 2A plus 80D over here, right? So this is essentially 40A plus 1600D over here. So I get one equation, which is S minus 1440 equals to 40A plus 1600D. Now, I have two unknowns, A and D, which means I need to form another equation. So where is this other equation? The other equation is actually in the first line of that. The sum of the first 40 terms is S. That means for this sequence over here, okay, I'm just going to write it here, erase all this. So I separate these two, right? For this original sequence over here, I add everything together. So T1 plus T2 all the way until T40. This will give me a value of S. So this S over here can be written as once again 40 divided by 2 because I have 20 pairs and each pair is T1 plus T40. So it's essentially 20 of A plus 39D, right? Because the first term is A, the T40 is essentially A plus 39 of D. So when I combine these two, I get 20 of 2A plus 39 of D. So expanding this, I get 40A plus 780 of D. So you see that I have two equations. Over here, I have equation 1. Over here, I have equation 2. So I can technically sub them into each other. Let's say I sub equation 1 into equation 2. What will I get? I will get 40A plus 780D minus 1440 gives me a value of 40A plus 1600D. Now these two will strike each other out, and then of course I can minus this over to the other side. So in the end, I get minus 1440 is 1600D minus 780D. So 1440 is 820D, right? And therefore D is just minus 1440 divided by 820, which eventually gives me a final value of minus 131 over 41 as the final answer to this entire question over here. So as you can see, this is basically simultaneous equation at its finest, tackling on this concept of the sum of an AP. So this question, I would consider this as more of an exam kind of standard question. But if you want more practice like this, make sure to click on the link in my description under this video. If you want access to my full library of more questions and more explanations from me just like this, right? But this is basically the type of questions that you can expect coming out in the exams. I thought of including it inside here because typically the questions that we go through in this entire worksheet over here is more so to introduce the concept to you, but it doesn't hurt to actually expose you to some exam standard questions. Right? If not, any questions, let me know in the comments below, and I'll see you in the next video to actually go through the concept view as to how to actually test for an AP systematically. I'll see you in the next video.